follow the scientific method. So we start with making observation in the market. So we are looking for those inefficiencies. We formulate a mathematical problem that corresponds to that inefficiency. And the whole purpose of that mathematical problem is to find a way to buy low and sell high. Then we use our skills in computer science, statistics, financial engineering, and AI to write algorithms, which are pieces of code that will solve the mathematical problem. These algorithms are capable of buying low and selling high systematically by exploiting that inefficiency. So once we have an algorithm that works quite well, we're going to optimize it. We take a period in the past, we simulate how the algorithm will perform in the past. And those algorithms, they have parameters. We fine-tune these parameters in order to find the best set of parameters. For instance, the parameter could be take profit, stop loss, typically. But it could also be like parameters that are specific to the algorithm that we are using. Once we've done that, we look at a period in the past that was not used during the optimization phase and apply the algorithm on that period. And we are expecting the algorithm to still perform really well on a period that is outside of the optimization process. And once this is done, we take the algorithm, we put it in our live environment, but we don't fund any money. We let it for 1 month with no money in it, just to test the algorithm and see how it works live. If the performance are going well, we're gonna incrementally increase the allocation that we put on that algorithm. The reason why we wanted to do incrementally, just for risk mitigation purposes. Once the algorithm has been performing really well, we give it the full allocation. But still, for risk management purposes, we keep monitoring, comparing how the algorithm is doing live with the simulation environment. This is what we call the post-trade analysis. We want whatever is being done live to be as close as possible to what is being done in our simulation environment. This allows us to be in control and also to check for anything that is unexpected. Throughout this entire process, if at some point the algorithm performance starts to decline, we look at whether the performances are getting outside of what was done during the backtesting when we look at the past. And if we are going outside of our comfort zone, outside of what was supposed to happen, then we start deallocating the algorithm progressively until at some point we remove the allocation and maybe we have to try something new or see what went wrong and improve upon the algorithm. So we have a very rigorous approach from beginning to end.